I'd like to start with a story. So it's the beginning of the year 1986, and the Challenger shuttle is preparing to launch for the 10th time in its history. So, and for the first time, it's widely watched because there's a school teacher among the crew, so lots of children are watching the broadcast, and suddenly, 73 seconds after the start, the shuttle breaks up into pieces. So the entire crew of 7 astronauts died. And why did that happen? Well, obviously there was a thorough investigation after the accident, and only then we learned that they were doomed virtually from the very start of the launch. And this was due to a leak in one of the 2 side rocket boosters. Basically, those rocket boosters are made of segments, and they are connected. Those segments are connected, so there are O-ring seals in between of those segments. It's just seals in between, similar seals as you have in your water pipes in your house. Obviously, different material and different size, but in principle, just an O-ring seal. So during this disastrous launch, one of those O-rings failed, and it allowed extremely hot gases to escape, which caused more and more hot gases to escape. So eventually, the whole rocket booster broke apart from the main vehicle, which caused the main vehicle to drastically change its course, and then it exposed the vehicle to forces so strong that it was not designed to endure. So it all broke up into pieces. And so why did this seal fail? Well, the evening before, NASA received a weather forecast that it would be an unusually cold morning in Florida, with temperature -1 degree Celsius. And they had huge pressure to launch because there was, they promised to launch a shuttle every month, and they were like completely behind the schedule already. And this particular launch was already postponed like 3 times. So they really wanted to do that, even though the weather was not so convenient. And so the rocket boosters were provided by a subcontractor company, and they were designed to work over 10 degrees Celsius. They didn't even test below that. So NASA really wanted to launch, so they got them on an emergency conference call the night before, and they asked, like, why cannot we launch? We must do that. And the engineers tried to say no, but the managers at this company called Morton Thiokol, they said, like, they also made pressure on their employees to give positive recommendation for the start. So eventually it came down to 3 people. 2 of them said, okay, yes, and 1 person still opposed to allowing for launch. And then the general manager, like the top man at this company, Morton Thiokol, he said, you must take off your engineering hat and put on your manager hat and then make a decision. So he did that. He stopped thinking like an engineer. He made a different decision. He changed his vote, and we know the rest of the story. The entire crew died of 7 astronauts. So this decision cost 7 lives. Of course, this was not like the fault of this one man. It was like tons of reasons for the whole catastrophe. But I think this quote is very powerful, and we should remember that. So now, as machine learning people, we are working on technologies that are super powerful, and they impact not 7 people, but billions of people around the world all the time, like during their entire lives. And after a certain point, the decisions are not made by engineers, they are made by politicians, by managers, and lots of non-technical people. So as a community, we really must shape the world so that AI is built and implemented in a way that thinks about the whole picture and not just about optimizing some metric or making profit or achieving just one impact on the world. We must think about the entire picture. So as the CTO of Epsilon, I care about lots of things that we do, about the models that we build, but also about the ethics of the models that we are building. And I have researched this topic quite a lot. And during that, I've learned about a number of stories that made a huge impression on me. So I'd like to share with you these stories, like 9 real-life examples and lessons that I believe we should all remember as people working in machine learning, whether you are a researcher or engineer. So imagine that you have a grandma and your grandma has healthcare and then it gets suddenly cut and she no longer has the care she needs. So this exactly has happened in the United States. So this woman is called Tammy Dobbs and she has cerebral palsy, which is porażenie mózgowe in Polish. So she's fully capable mentally, but she has to move on a wheelchair. She has stiffened hands. So she used to live in a state, Arkansas, where she was entitled to have a person come 3 times a day to her house. First time to get her out of the bed, give her breakfast, then in the middle of the day, and then in the evening. And without that help, she couldn't exist. And suddenly, a nurse comes for a re-evaluation, like every year, but this time she types all her data into a computer, asks some questions, and comes up with an answer that her insurance got cut to 30 hours a week, which is like, this might seem not a big change, but for this woman, it's like complete disaster. It's like life-damaging event. So only when there were lawsuits filed and they really investigated in court, we learned that this was due to an error in the algorithm because her particular illness was improperly encoded in the algorithm. To me, it's like a super clear example what can happen even due to a really small issue. Like you can say that such bugs happen, and that's normal. There were like several main issues in this story, and this affected like lots of people, not only this particular woman. So one of the biggest problems was lack of explanation to the public how this works, how this new system works. There was no explanation at all. So even the nurse that did the assessment, she wasn't able to explain anything. There was no appeals process in place. Like the only way was to file a lawsuit in court. And a huge issue, no one felt responsible. There were like several parties, software company, some researchers that created the initial model, and politicians in the state who made also decisions. The creator of the model, so this smart researcher who created it, he was asked like whether he felt responsible for alerting people how this algorithm worked and potential impact. He said, yeah, I should also probably dust under my bed. So he didn't feel responsible at all. And I can kind of understand that. Like from distance, it seems ridiculous that he didn't feel responsible. But when you're in the middle of work, you mostly work on optimizing some metric. You are deep into the coding problems. It's easy to lose the bigger scope. So I think this is an important story. So as algorithm authors, we must take responsibility for the entire picture of how it will be used, not only for delivering like our small scope of the project. And the responsibility tends to get diluted. Now, maybe some of you are aware that in the United States, there is a software used by judges. It's used to, it just gives a suggestion, right? It's not anything decisive. It's just a suggestion whether a person will make similar offense again or not. So the idea is super good. It can help to release people who just made one mistake and will not reoffend in the future. At the same time, keep arrested the people who would reoffend anyway. However, it's super biased, and it's not the difference in the data. It's not that black people are more likely to be criminals, because as you can see here, it's consistently biased. It's like labels higher risk people who, and like from the higher risk people labeled by this algorithm, it's twice as much was wrong for African Americans than for white people, and the same for lower risk. So it's just biased. It's not anything in the data, and this like huge impact on life. Even when they asked some white criminals, they were surprised that they were ranked low risk, and like guy said, it's like why was I labeled lower risk, and then he reoffended several times. Another example, like this is super famous example, but what I find shocking is like that this example it's still not fixed. It's been there for years. I've checked this week, and it's still there. So if you translate in Google Translate to Turkish, they have gender neutral pronouns. So you cannot say like O can be she or he. So yeah, you translate she is a doctor, he is a nurse to Turkish. It's correct, but then you translate back, and it translates to he is a doctor, she is a nurse, without any annotations that this can be. This is just one of the options. And so we have some bias from our society encoded in a product that's widely used, and it has huge budget, but this is still there. No one cares. So I think this is an important lesson for us to deliberately work to avoid bias in our models. And also yesterday we had a talk from Przemysław Biecek about explainable AI. So this is one of good tools to see whether we are biased. So we should definitely interpret what a model has learned, what are the features before putting it into practice. Another example that I would like to share is from a book called Weapons of Math Destruction. So this book has lots of examples like that. I can totally recommend. There was a person called Catherine Taylor, and she couldn't get a job. Like she got rejected all the time. And once she applied to Red Cross, and finally she got a denial with a clue. So they said, we don't want to work with you because you have criminal past. And she was, what? I don't have criminal past. I didn't do anything. And she started to search on the internet. She found a person who was named exactly the same and had the same birth date and was a criminal. So it's like a stupid mistake, but she really couldn't get a job. So this has huge impact on people's lives. So even non-critical systems, you don't have to be building a space shuttle, but still it's critical for individual lives. I think this is more likely for most of us to be working on these kind of systems. And let's remember that it's really a huge impact. Okay. So this lady is Rachel Thomas. She runs a data ethics lab at University of San Francisco, and I learned about several of these examples from her. And I particularly liked one of the observations that she makes that algorithms are used differently than people's suggestions. So if you think about the judges and the suggestions from the system that they are getting, the example that we talked about before, it's super hard to get a judge to make a nuanced decision. They're likely to treat the output from an algorithm like something objective and error-free. It's just the nature of people. And it's often happens that when we implement an algorithm, there is no built-in appeal system. So if you have this human decision makers somewhere in the world, we always think about, well, this person can be wrong. So what if he is wrong? What's the appeals process? And surprisingly, algorithms are often implemented without anything like that. So, by the way, I recommend her talk, her keynote from PyBay. Lots of great examples and thoughts. Okay, yeah. So people trust algorithms much more than we would think they do. Now, time for a more positive example. We have several people from OpenAI at this conference speaking. I think 2 weeks ago, they have released finally the large version of the model, GPT-2, the model for text generation. And I think this is a great example of what they did, because they noticed that the model was so powerful that it could be used in very bad ways. So in February, they just released a limited version and started a process. They invited researchers to experiment with the model. They built and asked people to build detection systems so that to see what's the accuracy of detecting whether something was created by a bot or not, and so on. And they finally released this model 2 weeks ago. So I think this is a great example of how we should approach those especially powerful models. And one of the tools they used that we can all use in our work day to day is model cards. And this was suggested by several people from Google. So such a model card in a standardized way shows the intended use, the misuse cases. It shows how the data was collected, so that some researcher can experiment and see what was and notice some mistakes in the process, and also, of course, some caveats, recommendations, and so on. So whether you are releasing your model into the public or just internally, I think it's useful to complete such a model card. And as an example, you can see what OpenAI put on in all those sections for the GPT-2 model. So yeah, OpenAI, I think, did this right. So we should always evaluate risks and communicate the intended usage of the model so that it's not misused. This is an example from last week. I saw this on Twitter last week. I hope you will be able to see it. So there are researchers from some university showing their model that will be used for entrance to London Underground. And they're super proud of the model. And what I was shocked with was that they don't mention any risks at all. They just go, wow, this model is super cool. It will be great, basically. And they don't mention what about law enforcement abuse, privacy issues that come up, surveillance, migrant rights, biases, and especially what happens in authoritarian states. Especially since China already has this massively rolled out, so all the citizens there, and this is huge implications. So maybe you're aware of the Hong Kong protests. So people in Hong Kong, of course, disguise their faces, and the situation in Hong Kong is very tense at the moment. However, I'm not sure if the Hong Kong protesters are aware of this paper for recognizing disguised people. And again, this is a paper like people work on this without any considerations. So I looked at this paper. I didn't see any concerns about the misuse of such technology. So it's easy to get media coverage for a cool model, but we shouldn't be like those researchers from Bristol. We should make sure that if we are featured in a video like this on television, we should make sure that it contains those risks as well, and it's not cut out. Another positive example that I would like to show you is it's a talk from Ivan Estola, who is lead machine learning engineer at Meetup, and he gave a really nice talk. It's just 20 minutes, so you can all watch. About the decisions that they have made in implementing their recommendation system. So in particular, they chose not to include certain features at all and not to optimize their metric at all costs, basically. So, so the recommendation system metric would give, without any special decisions, it would be very unlikely to suggest tech meetups to women, simply because there are less women on tech meetups. So this creates a feedback loop. There are less women on tech meetups. We don't suggest such meetups to them, so there are even less women there. So they made explicit decisions, and they used to have a simple linear regression model, so it was easier there. But when they moved to some more complex model, which was based on a network, they also made sure that in the architecture it was ensured that features like gender is not used for the recommendation directly. So it's a great example. And there's Goodhart's law, maybe some of you know it, that when a measure becomes a target, it ceases to be a good measure. I will have another example for that in a second. So we should always remember that those metrics that we have, like engagement, accuracy, and so on, these are just a proxy for what we care about. So we have the responsibility as humans to reflect our values and care not only about the metrics but about the final outcome. And there's this is the most shocking example to me. Maybe some of you are aware that there was a genocide in Myanmar last year. So thousands and thousands of people died, were killed or had to flee their homes. Most of them fled to Bangladesh because of ethnic clashes, and most of it was incited on Facebook. And Facebook finally admitted this year that they didn't do enough to prevent that. And they imagine that you introduce Facebook to a country where they didn't even have electricity 10 years ago, and it became a way for people to spread violence and violent content. So basically, the majority of people spread hate about an ethnic minority called Rohingya, and they had different religions, so that only helped increase the violence, and it ended really tragically. So the worst thing about this situation, I think, is that Facebook executives have been warned as early as 2013 about this thing being a problem. And after 5 years, there was huge outburst of violence, and it ended really bad. And even 2 years after that, they still had only four people reviewing the content in Burmese. So for sure not enough. So they just didn't care, right? Or didn't care enough. And another example from Rachel, she compared this to like two reactions from Facebook. One is to Myanmar, where Zuckerberg said, "Oh, they have added dozens of content reviewers for this language, and during the same year they have hired 1,200 people in Germany to review content." And why was that? It was because Germany passed a law that threatened Facebook and others with $50 million fine when they violated hate speech law. So this is a very clear example of how regulation can really help, because it makes managers and decision makers who mostly, like by nature, care about the profit. This helps everyone really treat risks seriously. Okay. So the same thing, it was like people said that cars can't be regulated in the early days of cars, and thought that people, it was because of the drivers, basically. And now we know that, like, thanks to years of regulation in cars, they have gotten much more safer. And this is like personal example about regulation. I have two super small children, so I've become an expert on car seats for children. So basically, it turns out that children are 5 times safer in rear-facing car seats than in front-facing car seats, even though they don't like traveling this way that much. And the regulation differs. Like in most of Europe, it's one kind, and in Poland, you still see lots of children traveling in a front-facing car seat. But in Sweden, they have regulation that requires the forces operating on children's neck to be limited to some level, and basically the only way you can satisfy this law is by using a rear-facing car seat. And the effect is clear. That only 15 children died over 11 years, while in Poland it's like 70 to 150 each year. So.
Can you compare now amount of people in Poland and Sweden?
Sorry, not.
Can you compare a number of people?
Yeah, it's like 3.5 times larger population in Poland. Yeah, you can compare all the factors, but I still think that you know, the disparity between those two numbers is clear, right? The population is 3.5 times bigger, more or less. But the point is that the regulation can be different. The regulation to AI will come eventually, but it's about when this will happen and whether it will be wise or stupid, basically. As technical people, we are usually opposed to regulation because it's often stupid. But I think this just means that we should work on this to be wise regulation. So we should advocate for wise regulation and treat it as our ally. Because coming back to the space shuttle example, if they had regulation at that point, the engineers wouldn't have trouble convincing managers to make better decisions and save lives. Okay, final example. At Upsilon, we invest quite a lot of our time in AI for good initiatives. So we work with NGOs to put AI models into work for preserving our climate, helping save rescue animals, and so on. And this is great, and I'm happy to see like lots of companies doing that, and more people becoming interested. But we should be aware of a phenomenon called technologism. So it's like there's a book from Kentaro Toyama, who was an engineer from Microsoft. He was sent to India to try to help social change and improve people's lives with technology, and he found that people are really making lots of mistakes by just going with their Western perspective and trying to fix everything with technology. So it basically looks like this, right? It's like, yeah, we will solve it with algorithms, and then, okay, yeah, you were right. It's really hard. So we should work with domain experts a lot and try to first solve a small problem with a really stupid model, but solve it with solve it really at the right depth, so right mix of technology and people and human knowledge, so that we build common understanding between domain experts and engineers. We need to learn what are the roots of the problems, and they need to learn what is possible with technology. And only then really useful ideas start to come up. So yeah, algorithms we build affect lots of areas of our lives. The ads you see, the news you read, basically shapes how you think. Whether a product is available, what price we pay for things, and so on and so on. As we saw on the examples, it affects your healthcare. It affects whether you can get a job. So given that less than 0.5% of global population even knows how to code, think about what a tiny fraction of that number are people who understand AI. So we have really huge responsibility for what this becomes for our society. So yeah, you know about problems and implications that other people don't know about, that hugely impact people's lives. So you have the responsibility to shape our future, the future of our society, so that it's bright. Thank you.